Hello, I am coming back to you for a quick update. I was not as thorough as I should have been for the implementation, specifically the analysis of, let's see here, the analysis of deletion. So insertion, it's always easy to get to the front or the end of a list to add something. You could be like, I need to make a brand new thing. Maybe, I don't know, 43. And I put it at the very end. I can save this old last thing, and then I can move around the next pointers, and it'll all work out. It'll still be constant time for insertion, no matter where, the beginning or the end, constant time. Okay, still constant space. Okay, that's insertion, and it's fine. Search, in the worst case, yes, that makes sense. O of n time complexity, because you might need to get to the middle. Deletion, I talked about pop front. And by not talking enough about pop back, I made a bit of a mistake in saying that it was O of 1, because it really depends on the list. Okay, so it's not the case that it's all that similar to pop front, replacing first with last. You do have to iterate through the entire list. You have to get to that second to last element. Okay, so let's see here. How do I want to say that? Let me do this and then also say it's not constant running time for push front. I'm sorry, pop front. Non-constant running time is linear for pop back, depending on the kind of list you have. And then that's where I want to leave us. So for example, if I had the list 1, 2, 3, and I wanted to remove, here's my first, here's my last, and I wanted to remove that 3 node, well, it's not enough to be like, yeah, get rid of the 3. Hey, what do I make last? Oh yeah, I'll just make it 2. There's no way to get back unless you have a certain kind of list that has back pointers, has previous pointers. That's called a doubly linked list. We've been talking about singly linked lists. So because we don't have access to that thing, we need to somehow go inside, delete that. We can delete last immediately. We need to somehow get the last to point right there. How do we find this 2? Well, we're kind of stuck. We have to iterate. We have to go through the list. And this really sucks if the list is very long. Like here's the last, here's the front. We need to get to the second to last element, and we need to iterate. So it's going to take linear time. Okay? So linear for pop back. Assuming you had a pointer to the previous node, it could be constant. But to be accurate, this is what it should be. Okay, so I think everything else, I didn't make any mistakes or speak too quickly. Insertion will always be O of 1 because you can put a new node into the first, then you can use the old first to set next pointers. Same with last. For deletion, or for search, yeah, it was already O of n in the worst case. Deletion, it gets a bit tricky. Okay, so pop front is easy because we can immediately find the new first quickly through next pointers. If you don't have a previous pointer, though, it's hard to find the new last using something other than iteration. Okay, so that's no fun. So it is not always constant in terms of running time. Okay, it's linear when it's deleting from the end, or deleting somewhere that you don't have access to. Okay, I think that's all I wanted to say there. Just making sure I have been precise.